find all the good in.
Yeah, go on, Bamshi.
Yeah, in this question, we are asked to find all the good indices. So first of all, he said that a index is good if there are k elements just before that index which are in non-increasing order, and there are k elements after the index which are non-decreasing order. First of all, non-decreasing order means every element should be greater than or equal to its previous element, and non-increasing order means every element should be less than or equals to its previous element. So if we take this example and the output is 2 comma 3. So at index 2, there are two elements before that index which are in non-increasing order, and two elements after that index which are in non-decreasing order. And similarly with the third index also, there are two elements which are in non-increasing order, then two elements which are in non-decreasing order. So the brute force approach will be, for every index, we try to find if there are k non-increasing and k non-decreasing elements after that and previous that. But that approach will give us TLE. So let's try to find an approach. So let me take it here.
Okay, while Vamshi is writing this array, so mainly two things typically come to our mind when we see this kind of problem where we have to run two inner loops, one moving backward, another moving forward to find something out. Then typically, like from past experience of solving problems, I feel there are two alternates in which we can think. I guess, can you tell me what are the alternates that come to your mind? There's an outer loop, and in brute force approach gives you kind of outer loop and either one nested loop inside or two nested loops inside. Does that ring any bell of what could be kind of one way to think about optimizing? Okay, in my experience, I've seen those problems typically turn out to be either prefix sum problems or stack based problems.
Yes, sir.
Okay, go on, Vamshi.
So let's try to create two more arrays which are basically prefix and suffix. So where I'm trying to find out length of the longest subarray which is non-increasing, and ending I.
And here it will become starting at I.
Yes. So let's try to fill this table. By the first element will always be non-increasing. While filling from the second element, we compare the element with its previous element. So if the current element is less than or equals to its previous element, then we can extend it. So we will add 1 to its previous number. So this will become 2. And here also our current element is less than or equals to its previous element. So we'll extend it 3. Same here, we'll extend it 4, but we can't extend it here because our current element is bigger than the previous element. So we have to start fresh. So this will become our new ending 1, and here Same here, 1, here will be 2. And we will fill this backwards. So first element will fill directly 1. Here, our current element is bigger than the next element. So we need to fill 1 because it is in decreasing order. We want it non-decreasing. So here it is increasing order. So we put 2.
Then
Here
3.
we put 3, then 4, then 5, then 1. So if we want to tell if an index is good or not, we need to check its previous index non-increasing and after index non-decreasing. If both of these values are greater than k, greater than or equal to k, then we can tell that that index is good. So here at index 2, non-increasing of 1 is greater than or equals to 2 and non-decreasing of 3 is greater than or equal to 2. So 2 is a good index, and same with 3. So non-increasing of 2 is greater than or equals to 2 and non-decreasing of 4 is greater than or equal to 2. So 3 will also be a good index. And there are no other indices which are having non-increasing of I minus 1 greater than or equal to 2 and non-decreasing of I plus 1 greater than or equal to 2. So 2 and 3 will be the answer for this part.
Yep.
This was my approach. Yes, sir.
Yeah, same was mine also. Anybody else use any other approach? Okay. Cool. Yeah, thanks, Vamshi.
Yes, sir.